Hey guys, last time SN commented on one of the videos, so he recommended problem D in the same round, 590 division 3. All right, so let's working on this problem this time. So here is the problem, and I will introduce the problem by illustrate example. All right. So the example is here. The input is a string and a bunch of operations. 5 here is the number of operations. 1, 2, 3, 4, 5. 5 operations, right? So there are two kinds of operations. Let's introduce the type 2 operation first. All right. So this is the type of the operation, and it is to query from position 1 to 4, position 1 to 4, the number of distinct characters. So it is A, B, A, C, right? So A, B, C, 3 kinds of characters here. So the output is 3, right? So how about type 1 operation? So type 1 is change the character at position 4 to B, right? Position 4 is here. We change this character to B. And let's move on. Another type 1 operation. We change position 5 to B, right? So now the string we got is A, B, A, B, 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 A, right? So let's do operation 2 again. And this time we query from 4 to 6. 4 to 6. So all B's, right? So only one type of characters. So we return 1. And the last operation, query from 1 to 7, is the whole string, right? As we can see, two kinds of characters, A and B, right? So we return 2. Okay, that's that's what the problem is about. So let's think how to solve this problem. So the most naive way is to maintain this string. And when we encounter each operation, for example, operation 1, I mean the first type of operation, we just update the string, right? It can be done in O1 time, right? So what about type 2 operation? Type 2 operation can be at most from 1 to n, right? So we check the characters from 1 to n and count how many distinct characters are there. So the complexity is O(n), right? So there are at most n of operations. So we needed to multiply by O(n), right? So in total is n squared. Now we check the range of n. It can be 1,100, right? So if we do it in n square, it won't pass the exams because it's too large, right? You will get a time error, right? So let's Let's try to solve it in other way. We need to use segment tree here, right? Let me introduce this structure. It is called segment tree, right? So basically, it's a tree, and this tree has some special properties. Let's show it here. Right? We save the stream in the uh, lowest level of the tree, right? This is the lowest level, and this is the stream, and we save the characters in the lowest level. So what about their parent? For example, node 3. Node 3 is a sum up of its child, 7 and 8, because 7 and 8 respond to the first and the second characters in the string, right? So the node 3 saves the state of the first two characters, which is 1 and 2, right? In the same way, the node 4 saves the uh, third and fourth character in the string, right? Also, for node 5, it saves the fifth and sixth character. The node 6 saves the seventh character in the node, right? So what's the state? Because in the end, we need to get the number of distinct characters between some range, right? So we need to save the number of distinct characters. Actually, we are going to count the exact number of the appearance of each character. For example, from position 1 to position 2, there is 1A, right, here, and 1B here, right? And for position 3 to 4, there is 1A, right, here, and 1C here, right? So we go up another level in node 1. Node 1 saves the state from 1 to 4, right? Because its left child saved the state from 1 to 2, and its right child saved the state from 3 to 4. So in total, node 1 saved the state from 1 to 4. And from 1 to 4, it has two A's, right? It has 2A. And it has 1B and 1C, right? Also, let's go to this side. From 5 to 6, it has 1A, 1B, and 7 at 7, we have 1A, right? So in total, from 5 to 7, we have 2A's, right? 2A and 1B, right? So we got the state of node 1 and node 2. Now we have enough information to go up another level. So in the 0 node. Node 0 goes from 1 to 7, right? So in total, it has 4A's because there is 2A here and 2A here. So in total, 4A's and 2B because there is a 1B here and a 1B here and a 1C. There is a 1C here. So let's check the correctness of this structure. From 1 to 7, how many A's are there? There are 1, 2, 3, 4, 4 A's. How many B's? 2, 1, 2, 2 B's, right? How many C? 1 C, right? So this structure is correct. So how do we keep this structure updated? Because we have operation 1, right? At some point, we might need to change one character in the string. For example, we need to change 4, right? We need to change here. How do we update this structure and keep the structure's property? So we do it from bottom to top, right? First, we change here, B, right? We change from C to B, right? So what does it mean? It means its parent, C, should decrease by 1. So this C should become 0 now. And B should increase by 1. So we should change it to 1, right? And also, we need to update its parent, right? First, decrease C by 1 and increase B by 1, right? And also, its parent need to be updated from C and B, increase by 1, right? So in total, there are 3 B's from 1 to 7, right? 1, 2, 3, 3 B's, right? And 0 C, because C already changed to B, so there is no C here, right? That's how we keep this structure updated. So let's assume this structure is updated. How do we make a query? For example, we need to query from 1 to 4, right? We need to query from 1 to 4. At this time, we need to query from top to bottom. So as we all know, the top node has the state from 1 to 7. So this range is bigger than our query, right? Our query is 1 to 4, but it is 1 to 7. So there is no use of this information in the node, right? We can't use it. So we go to its child to look for the information. So how about left child? Is 1 to 4, right? Cool, it's inside the query range, right? Query is 1 to 4, and we have the 1 to 4 here, right? So we can get this information. This information is exactly what we want, right? And we go to the right child. The right child is from 5 to 7, so it's not in range. So we just stop here, right? And so the end result is 3 characters, right? So we output 3 here. Okay, let's have another example here. We query from 4 to 6, right? So we first check the root node. It's 1 to 7, so it's too big. In this case, we go to its left child first, right? We will go to its right child very soon, all right? We go to the left child first. Left child is 1 to 4, right? 1 to 4 is has the intersection with 4 to 6. So we go to its child again, right? Left child. So it's 1 to 2. 1 to 2 is outside of 4 to 6, right? So we stop here. This information has no use, right? And we go to its right. So it's 3 to 4. 3 to 4 also has the intersection with 4 to 6, right? So we keep going to its left child. As we can see, left child is 3. So 3 is outside of 4 to 6. So this information has no use. So let's go to its right child. The right child is 4, inside 4 to 6. Cool. So we got this information, right? We keep count here, C equals 1, right? And we go back one level because we already got all the information in the left child. So we go back and go to its right child this time, all right? The right child is from 5 to 7. 5 to 7 is intersect with 4 to 6. Okay, so we go to its left child. The left child is 5 to 6. Okay, so 5 to 6 is inside 4 to 6, right? That's great. So we can use this information. A equals 1 and B equals 1, right? Cool. And we stop here and go back. Then go to its right child. Its right child is 7. 7 is outside of 4 to 6, right? So this information has no use. So we stop here and go back. So this information we already got. So the end result is B equals 1 and A equals 1 and C equals 1, right? We have some problem here. 4 to 6. Oh, I see. We didn't update these two B's here. So in this case, we'll query these 4 characters. They have 3 different characters, right? One is A, and one is B, and one is C, right? So we have correct answer. All right. So I guess that's it. It's a very typical segment tree solution. So what's the time complexity of this solution? If you have a type 1 operation here, we need to update the lowest level node and go up, then go up, uh, up until the root, right? So it can be log n times, right? So what about the type 2? We can we start at the root and go downward, 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 uh, downward, downward, right? Is log n as well. So the overall complexity is n times log n, right? So this complexity uh, is good, right? Our algorithm can survive this problem. Okay, let's see the code here. Here is the code, right? This is the main function, and we initialize the segment trace node, right? And read in the string, and then for each character, we update it, right? Because at first the tree is empty, right? The lowest level is empty, so as the upper levels, they're all empty. And we update the tree, uh, update the character one by one, add it into the tree, right? So we update n times. In the end, we got a fully functional segment tree in the end. And then we take in the all the operations. First, we get the type of the operation, right? If it is a type 1 operation, we update it from bottom to top, right? How to update it? So we first increase the new character by 1, right? And decrease the old character by 1, right? This is the new character and this is the old character, right? After that, we go up one level, right? This part is where we go up one level. And when we encounter type 2 operation, we get the left and the right, the queries left and the right. And we query it, query the total number of distinct characters. So these two character, these two variable here is the left and the right number of the node in the tree, right? Like this node, it contains the information from 1 to 7, and this node contains the information from 1 to 4. And in the code, this two number is respond to the range of the node's information, right? So if the range is outside of the query, right? This is our query's range. So if it is outside of the query, we just simply stop here and return. If it is inside the query, we just take this information and add it into our answer, right? And then if it is neither, it means we have an intersection, right? So that we need to go to left child and, and go to right child. It is a deep first search, right? After we do the query, we just simply output the answer. Okay, I guess that's it. I hope that would help you, man. Thank you for watching.